So these are the people speaking. This is not the order. So if you're up here and you want to go next, maybe you have to leave early. Does any of these speakers need to leave early tonight? All right. So anyone want to volunteer, or otherwise it's David?
Batter up.
We'll just go in order.
All right, we'll go in order. David's up next. David, what is your topic?
I'm going to demo what we do at Brainspace.
Okay. So by the way, I can tell you that it's incredibly difficult to talk for only 7 minutes once you get going. So, as they say, a speaker, anyone who speaks can talk for an hour easily. It's much, much harder to talk for 7 minutes. So 7 to 10 minutes.
And where's the?
It's that green. Do you need DVI? Because I have a
Just say this works.
We have more chairs over here. If someone comes in that doesn't have a chair, there's more down here.
We have lots of folding chairs. No one needs to be sitting on the floor or on a desk.
All right, y'all ready? So my name is David Hagar. I work at Brainspace. We do NLP and text analytics for the legal industry. And as I've been as part of this group and had conversations after the meeting, it's always been a little bit of a challenge to explain what I do and sort of how it applies to this group. So I wanted to sort of collapse all those conversations into a single conversation and do it in 5 or 6 minutes. The first thing I want to start off, I was in Austin this weekend, and there was a wonderful event called NLP Community Day. If y'all know any of the sort of the day-to-day Texas events that are down there, they're very, very nice. I was very impressed with what they did. I got this cool t-shirt. One of the things I want to talk about, people talk about models and they talk about data science, but what I'm going to demo tonight is an application of data science for a real product. So these are our actual customers that use this tool in the legal industry. And you'll see some very big names up there: KPMG, PricewaterhouseCoopers, LexisNexis, Pioneer is an oil company, Huron is a legal service provider. There are a whole bunch of very, very big names up there. And we're very excited at Brainspace that we're able to get that going. So I'm not actually going to run the web application. So I have recorded this, and I will talk about it as it goes. So there's 3 components to this application. The first one is concept search. And you may have heard of term expansion. This is used in NLP. This is latent semantic analysis. And latent semantic analysis uses singular value decomposition, a common library in many sort of open source products. And what it does is in the NLP space, it gives you these huge long lists of synonyms, and in this case, this is a Wikipedia data set, and I did a query for big data. And it does a concept expansion on that. And you may have seen this, it's very common. Word to vec is another way to do that. We have our web application grabs control whenever the login times out. So give me a moment here.
Linear A in the background.
Yes, of course it has jumped ahead, so I'm going to rewind. All right. And we use it to do search. So when you generate these long versions of synonyms, we expand them and use Lucene, which is an open source keyword search engine. Part two of what we do is k-means clustering, particularly hierarchical k-means clustering on text, on documents. And we built this visualization for navigating. And over, you see these little red lines? Those are the search that I did for big data and where they occur in those clusters. So we integrate search with k-means clustering. And this is all a web application. This is WebGL, and I built it. So if anybody's curious about what's going on here, I can talk about that. And not only can you do search with keywords, but you can also do search with clusters. And so in this case, I've sort of narrowed my search to this particular cluster. And people who are doing investigations, this is really, really valuable because they don't have any organization to their data at all. Right? So we come along, we cluster it, we allow them to search for things that they're interested in, and see it as a picture. And pictures are really cool. That helps sell things pretty nice. One last piece here. So there's a really common data set out there called on the inROMs, where when it folded, there's a lot of emails. So, well, there was some litigation with all the shareholders and things, and somehow the data set got public. And so now everybody demos it. And one of the things that we do, you may have heard of like Neo4j and these sort of graph databases, is actually show communication with inside of emails. And so we do these sort of graph layout thing and sort of display who's talking to who. But we do this dynamically on a query. So this is the entire data set right now. But here in a second, navigating through, sort of showing how you can focus on things and sort of show who's talking to who and how much. Come on. There we go, now we're doing the search. And then once you do a search, you change the active data set. Yeah, so we're searching for oil and gas. And we show a sort of different network of sort of who's talking to who for that search. And this is something you don't see in a lot of those sort of Neo4j kind of things. It's sort of a dynamic graph based on a search, right? But it's again, when you're doing investigations, it's extremely useful to discover a particular interesting set of documents, and then to see sort of the story of who's talking to who in those documents. I believe.
That 450,000. How many emails is that?
Yes. So this data set is about 500,000, 450,000 documents. I think Wikipedia was 4 million documents. We go up to maybe tens of millions in that range, and then things start to get challenging. So that's it. I'm done. Any questions?
Yes, the distance between the dots are all in the 2D dimension. What does the space mean?
So the positional layout tries to place people next to the people that we're talking to. So it's entirely graph-based. Okay, so if I'm sending emails to you, it shows up as an edge, and I try to move people around so that people who talk to other people are distant.
Does the visual distance mean something exactly that?
It does not mean anything. The distance has no meaning whatsoever. It's just a way of sort of showing groups. Right?
So then are the strengths of the lines just multiple conversations?
Yes. So the lines themselves have directionality to them. So you can see that this person right here is doing a lot of sending. Right. So this is thick end of the line, and this is thin. And you can also see that the thickness is significant. So For example, like, this person is not sending very much between whoever he's talking to. But this is a large amount of communication. And it tells the story of who's doing the talking. So this guy's doing the talking, and this guy's doing the talking. And everybody else is listening.
David, you have a question?
Oh, yeah, let's do this side.
So you mentioned tells the story, but I don't see any temporal nature to the display. Is it the temporal nature there?
That's correct. There isn't a temporal nature.
So how do you tell the story then?
All the other aspects besides temporality. Right?
Oh my God.
Yeah, okay. So who's talking to who, what they're talking about. So one of the interesting things here.
And if you can project on words, you can probably project on temporal and create.
So we've got this section down here called top terms. So like you can click on one of these edges, and it will tell you what the conversation is about. Right. And the aspect of time is something that we recognize as something that's really, really valuable, and we're currently working on ways of doing that.